For a given motor vehicle, the maximum achievable deceleration from braking is approximately 7 meters per second square on dry concrete, and on wet asphalt it is approximately 2.2 meters per second square. Given that 1 meter per hour corresponds to 0.447 meter per second, find the total distance that a car travels in meters on dry concrete after the brakes are applied until it comes to a complete stop. If the initial velocity is 67 miles per hour or 30 miles per second, or if the initial braking velocity is 56 miles per hour or 25 miles per second. All right, we'll focus on the first case here in this problem. So let's find the total distance that a car travel in meters on the dry concrete. So I know that from the problem it says right here, the maximum achievable deceleration from braking is approximately 7 meters per second square. This is the second derivative of the position function because this is the acceleration or deceleration function. We let s of t to be the position function. Then v of t is the or let's use s prime of t, the first derivative of the position function. That would be the velocity. And then the acceleration or deceleration would be the double derivative or double prime s double prime of t. This is the acceleration or deceleration. Okay, so in this question we are given the fact that the deceleration is 7 meter or double derivative, right, of s of t is equal to minus 7 miles per second square. Make sure that we include a minus because it is the deceleration, it is slowing down, right? So it should be negative versus the acceleration, which would be a positive value. So s of t, right? To find that, first thing we'll find the if you are given the acceleration, the deceleration, you can find the velocity by taking the integral of the position, the deceleration, right? You can do the integral, so that would be 7 times t plus initial velocity or a constant. That will be s prime of t. And I know that your initial velocity, we want that to be, or initial velocity, 67 miles per hour, or in this case, we're using meter per second square. So we have to go with meter per second for velocities. That should be 30 meter per second square per second. So that would be minus 7t plus 30. Okay, that is my velocity function. Now I want to find the total distance, which is s of t, right? And s of t is just another integral of the velocity. So I'm taking the integral, right? I'm taking the integral s prime of t. I'm taking the integral of the velocity, or I'm taking the integral of minus 7t plus 30 dt. And I want that to come to a complete stop. So we will go from 0. Now, if we want the initial, if we want the velocity to come to a complete stop, we have to set the velocity equal to 0 and see what is the time that makes it 0 to get to a complete stop. So s prime of t is your velocity. Set it equal to 0, then you can add 7t in both sides, and then divide both sides by 7. That will be your timing where it will come to a complete stop. So that will become the upper limit of this integral. So we take the integral of this velocity from 0 to this time to make sure that it comes to a complete stop. And that will, if you take that integral, it will give you the distance traveled, the total distance traveled of the car. So using you can quickly use a graphing calculator, Math 9, and I go from 0 to this number 30 over 7, and I will get minus 7x or t whatever, right, plus 30, and then dx, and that will be 64.3 meters when I'm using the 30 meter per second for my initial braking velocity. Now if I change my initial braking velocity to 25, so all I do now is I just replace the 30 by 25, and I can do that quickly here, minus 7t plus 25, that is my velocity, right? And I can solve for the timing to make it 0, so that will be minus 7t plus 25 equals 0, or 25 equals 7t, or t equals 25 over 7. Now the same rule, we will apply the same thing just like before. Instead of having the 30 over 7, now it is 25 over 7, and instead of 30, we will change it to 25 because my initial velocity now is 25, and that will give me the total distance traveled 44.6 meter.